Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on KanoScript. Alright, so let's see. So yesterday, last stream, started working on arrays, right? And today I would like to be able to index them. So we can declare arrays, and they get stored in the memory and all that, but we don't have any way to read from them or write to them. So let's see. Well, let's actually first look at what we got thus far. Let me just rebuild really quick just to be sure. Okay, and let's see. So basically, we have this Kano.Kano, right? So you can clear this. So this is the size of the array, and then these are the elements of the array. It's gonna be 0 index, so better than Lua, of course. Yeah, so I'd like to be able to do this basically. So x3 equals 15, not 3, because that's too much. X0 equals 15, something like that. That would set the first element to 15. And also indexing it, so we can do y int equals x0 plus 5, something like that. So that sort of thing. So pretty simple, pretty much. Shouldn't be that complicated to do. Yeah. So we can look at what this compiles into, and then see what we need to compile that into. So I'm going to start with reading from it first. Okay, so I already did that. So we can compile this main and we can look at what the assembly looks like. So I didn't add any labels. I forgot to do that actually. I was kind of in a rush yesterday. But this basically is how it works. So we push 8. That is the size of so it's like size of int 64 because that's what we have. And then we push 3. That is the size of the array, right? The number of elements. And then we multiply them, obviously, because it takes number of bytes. And then call alloc, and that will allocate the space in memory, right? Then we duplicate the pointer, and we push 0. This is like the index that we're pushing, because we write to it. Then we add, we cast it to a void pointer. And then this is the data that we're writing, and this is the size that we want to write to it. Yeah, and then we write. Pretty simple. And then we do the same thing, and this time 8, so that is, that's this, like the offset, basically. So this is like the first index, right? So it's like, it's really like 1 times 8 is what that means, basically. We add that, and we push 2, and we write to it. So we basically do that. And then to read from it, so right now we have the pointer on the top of the stack. Say we wanted to read the first element, or the second element, rather, at the index of 1. So you can duplicate the pointer, and then we need to push the offset, right? Because that's what we're going to read from. So 8, because that's 1 times 8, as I was saying before. And then we have to, so let's see, so that is, that's the offset. So we need to add that, and then cast it to a void pointer, right? And then we have to read from it, so we need the amount of bytes to read, so 8 in this case. Then we can call read. And that should read and place it on the top of the stack. So if I print it out, assuming I did the order correctly, this should print out 1. So let me try to build it. Oops, that's that. Okay. Fire, Kano, 10, and print it out 2. So that's not right. That's not good. No, that is okay. Yeah, because I didn't do 0, 1. Yeah, so 2 is actually correct. That is at index of 1. So let's try the next one. So it would be 16, right? So yeah, that was right. So this one should be 3. So here's the offset, 16. Let's try that, and let's file it for assembly, and there we go, 3. So that's sort of what we have to compile it into. Shouldn't be that complicated. Should be quite easy actually. Let's go into the source, and we'll open. Not really main.c. So front end.c. We'll start there. So whoops. Front end. C, there we go. So yeah, we'll start with the parsing, because the lexing already is all in place, because there's not any new symbols or anything like that. So parse, let's see. Basically it's in the parse primary is what we need to modify. That's right here. So if it's an ident, so this is for function. It's for a function. Then we have to do else if token p. So if it's a so if it is, what's it called? Well, do we need to do that actually? Because we had this. Yeah, because we need the index. If it's an open bracket. Yeah. Then so if it's token p tokens 0 type equals tt open bracket, then we're gonna do some stuff. So we want to, it's gonna look like this. But we have to parse the expression of that, of like the inner part of it. So we need to do this first. So we'll declare the initial expression. I said this expr type is expr array, and the value. So we're not gonna have value.variable, but it'll be, well, we could have value.variable actually. Let me look at how that is defined. The expr value should be in here. Yeah. So we have string view variable. So that's the name. Then, yeah, okay. That's all that we have for that. So is that, we need the index though. So we really need, yeah, we need like array. And we'll just create a struct here. So type that struct. So that's going to have the name, right? The name, and then it's also going to have the index. So it's going to be an expression, right? So index. Yeah, so then you can use like 1 plus 2 as the index if you need to. Or non-identifier or something like that. I'm pretty sure that's all that we'll need for this because, yeah. Well, we need the type as well. Yeah, okay, so we need, well, hang on, how do we do this without the type? Well, we're going to need it. So, we will just have a type. Okay. It's kind of fun. Alright. So, see, we'll go back here. Parse. Okay. That's where we're at. Basically. Yeah, so it's expr array. I did not add that type. I forgot to do that, so that's probably something important. I'll do it actually, though. So value.array.name is that. And then we don't know the index yet. We do have the type, though. No, we don't have the type because, well, that we don't need to store the type because that's stored from the name. Actually. Well, hang on. So yeah. Okay, yes, we don't need the type, but we do need to seal that. So we need to then token consume tokens, and grab the. We basically need to do the same thing. Yeah, pretty much that. It's not much different than a function. It's just replace this with a close bracket. And there is not, well, actually, no. Hang on, let me think. So we don't need to do that. We just need to consume, and then we just need to parse the expression. Yeah. So expr arrow value dot array dot value equals parse expression. So that's what we can do actually. And then we have to do append. No, because we did, we return the expression. So that's all good. That's actually all that we need then, in this case. Yes, that should be good. So now we can add the expr array and we can remove that type. We don't need the type because we have the name and we get that from the list of variables. That's in here. Let's see, what is it? Expr type. Oh shoot, I didn't even give this a name, did I? This is array. Yeah, array. Okay, and then we need to add the whoops, that's not right. Expr. Yeah, it's not right at all. Hang on. I broke something now. Expr func call, that's what we want. I accidentally removed that. Okay. This is expr array. Like that. Okay. That should actually compile now. Okay, it's just R. That's fine. Okay. Array has no member name value. What's it called? It's the name and the index. Okay. Yeah, because that's the index that we're accessing. So that's why I call it that. That makes sense. Parse primary. And let's see. So dot index. There we go. Parse that and assign it to int pointer. Okay, so I guess we don't have that. Yeah, because it's part of the expression. So that's not going to work. I'm going to need to modify this. So extra value. So I need to struct, basically. Okay, there we go. So that compiles. So should work. So now we can actually get to the compiling of it. Yeah, so we're able to parse it now, and then we need to go into here and we need to add it to the gen expression. So we have this expr bin, and then case of expr array. It's expr array. Then we want to okay. It's similar to the variable. We want to get that, and then we have to actually generate the index based on it, right? Yeah, so I'm not allowing something where it's like, you do that with the array. You can't reference the whole of it, just a slice of it, or an index, or whatever. Okay, so you get the variable, and it's not value.variable, but it's value.array. Array.name. That's what we pass there. Array.name, something like that. Then we duplicate it, right? So this is grabbing the pointer to it. So then we have to generate the offset and then read from it. So we can gen push state file, and we want the expert, not, oh shoot, yeah, so it is expert array.index. And we actually have to generate this expression as well. Okay, so we can actually just call it gen expression. State file expert value.array.index. So that's going to generate that expression, and then we have to add. We have gen add. Alright, we have this. So we need to basically do that. Alright, except for that, it is just an add. It's always going to be add. Okay. So we can just do that. Yeah. Like I said, I need to grab all that, but that's fine. Yeah, then we decrement the stack size because add consumes one of them. Well, it consumes both of them and it pushes a new value, but you know. And then we have to cast it to a void pointer. So to void pointer, I think I have that. And that does not consume anything, so let's pass the file there. And that would generate that. I think that function exists. I can make it if not. Okay, so we have the void pointer at the correct index. Then we have to actually write which I did not finish the parsing. No, I did. Okay. Actually, so is that fine? So we have the pointer. Then we have to read from it. Yeah, so we have to then read file and also the state because that's going to consume. How many elements did it consume? Let's see. Do I still have it there? No, this is the wrong place. Let's see. So we have read. So that consumes. Yeah. So we have to push the type size, and then it consumes 2 of them. So I'll have to make that, but we have to push the type size. So gen push state file, and then we need how are we gonna get the size of it? We have a thing for that. So op types. That's not it. What's it called? It's op data something. No, it's not op. It's data type. Data type size is what it is. And we don't have the type, but it's stored in the variable, so we can get it. Okay. That's what we're going to need. So we're going to probably need to call a function. Do we have a function to get a variable? Because we can get the location of it. But do we have another get variable location? Because that stores the stack position, but it also has the type. So it'd be nice if we could get the. All right, we'll make a new one for this. And just get variable type, right? So I probably could make this, which then each one calls it, but like if type that out, but that's fine. We'll return the dot type, and yes, it's gonna return a type. Okay, something like that. And yeah, so we just need to get variable type is what it will be called. Right? Okay, we need the state and the name. That's all good. So yeah. So we'll do type equals get variable type. Yeah, so obviously that's not exactly very efficient because we sort of call it twice and we have to iterate over the whole thing. So we could, there's sort of 2 ways we could we could fix that. We could implement a hash map, right, where it stores the name as the key. Or we could just iterate through it once and then save it to a variable and then get it from that. So either one would work. Yeah, but we should be able to do this. So for now, this is fine. So we'll just put the type here. And then generate read. So we need to implement gen read. Let's go gen write. We have that. Okay, so gen read. Right, write actually consumes 2 things though, doesn't it? Doesn't it? Yeah, because it consumes the pointer and the data. Okay. pointer and the data. Wait, so what is this 8? Actually, might consume 3 things. So we push 8, that is the size. Push 1, that's the data. And yeah, so it consumes, well, it consumes 2 because, wait, no, it consumes 3. Yeah, because it consumes all 3 of those things. Yeah, and the same thing with read, or yeah, so both of these. Okay, this is read. That's it. Alright, so that should be good. So let me try to compile it. Yeah, we don't have void pointer. Okay, I'll just do this because it's not that big of a deal. Right, yeah, I think that's fine. Alright, and let's go here, and let's try to run it and see if it works. So, let me look actually at the generated settings. So, we should be reading from it. I don't see any, there's not a single read. So did I, actually, I think I removed the example. Yeah, okay, so we want y int equals, not really x int that either. What's with y? Equals x 0. So that should be 1. Alright, and it failed. Okay, that's in the parsing, I would assume. Yeah, so I need to actually consume one more element, it looks like. Parse primary, right here. So I think we have to do a consume at the end. Yeah, because we have that extra bracket. Okay, makes sense. Let's see. Main cleaner. Alright, so that compiled now. And yeah, I'm gonna let that be in a second. So, we do have read. So in loop 0, that grabs the pointer. We push the offset, and we add. Cast it back to a pointer, because it turns it into an integer when you add like that. So you have to cast it. And we push 8, that is the amount of bytes to read. And then read, and that should push on the top of the stack. Push the value at the index. So it should be 1. Build chasm. Whoops, no tip. There we go. And echo, that is 1. Alright, so let's try changing it now. Yo, Stam, how you doing? Try accessing the second node. So there's no, like, a bound checking or anything like that, so if you access out of it, it's gonna lead to some problems. So I'm not gonna try that. Yeah, and I'll implement, like, stuff like that, like, safety features, you know? Very, 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 very good. Well, that's good. Something happened? Or is it just a particularly good day? Good day for no apparent reason. Alright, chasm and tired. And 0. That is incorrect. That's not good. No, just good. Oh, okay. Alright, why is that? Oh, shoot. Because I pushed 2, but I forgot to consider the type, right? So it's not, basically, it looks like this, right? We have 1. We have 1, 2, and 3. But each one of these is 8 bytes long because it's a 64-bit integer. So we have to account for that. So this should actually be push 16. Yeah, so I completely forgot about that. So that's going to be in here. Gen expr. Gen expr. Let's see, right here. Yes. So let's see. Basically. Yeah, so we have the index. So we have to do the index times. So yeah, then we can just push the size, and then we can multiply, and then we'll add. So, actually, we do have gen offset. Let me look at that, because I think I can reuse that. So, yeah, we pass the offset as an integer. Shoot, we can't really do that, though. Okay. Yes, that's not exactly going to work. Gen expression. Yeah, so we can't reset. So I should probably change that function. Now I can do this. So, gen the expression, then we can push the type size, which is this, and then we can print f file mol. I think I had gen mol actually. File, so I can use that, and then we'll add. So that will multiply them together. So that should be the correct thing. So that in this case it'd be 2 times 8, so it should be 16. Let's see. Gen mol does not exist. Okay, so I guess we don't have gen mol. So I should probably make that. But it's fine here. So I can just do this. Okay, and type is undeclared yet, so we can just get the type right at the start. Let's actually not do that if that fails. I think that makes sense. Yeah. Okay, main clean panel. And now we can look at the assembly, and it should be push 2 and 8, and then we'll multiply them together, so it'll be 16, and then it will add it to the pointer. So it should work this time. Asm, build tire, panel, tip. Like that, and 3. There we go. Okay, so yeah, now we can actually access elements in the array. So let's do that plus 5, so this should be 8. 8, there we go. Okay. And we should be able to make this larger. 4, 5, 6. And let's see, so that is 3, 4, 5, 6. 6. Okay, and then we can grab the 5th element, so that'll be 6, so that should be 11, right? Want to test, make sure it's all working. And 11, there we go. Okay, so we can access the elements, but we still don't have a way to reassign them, right? So that's what I'd like to do now. So let's try maybe x5 equals 27, right? Something like that I think would be good. So we can change the value of it, and then then in here this would output 27 plus 5, so that would be 32. Yeah, so we want this to output as 32. So to do that, it's going to be quite similar to this. Quite similar indeed. So yeah, so let's start in the parsing because that is where we need to start, because we have the lexing still. Actually, maybe I will commit this. That's probably good. Okay. Let's see. So implement ability to access the index array. Right, and there you go. Okay, so yeah, let's start here. Parts. So in here, it's going to be similar to the handle variable declare or variable reassign. So that's right here. So if token is equal, or it's going to be actually very similar. So grab this. So if it is open bracket, then the type will be, I need to create this type, but it will be array index. Is it array index? Because we're not reassigning the whole array, which I'm not going to support just yet. Yeah, so I'll probably throw an error like that. I'll need to see what that is. But yeah, so you can do this, and the value.var.name. Okay, we can't really, because we need the index as well. So this will be, it's going to be a bit of a different thing. But then we token consume that, and we push the value is that. So we still need the value that we're assigning it to. So it's an open bracket, and then we have to parse that. So okay, here's what we need to do. We need to token consume. So this gets the identifier. We're gonna have to, we'll change it to array.name. What was that? Then we have to consume. This consumes that, and this will consume the open bracket. And then we have to parse the expression in there, and that's gonna be the node value.array.index equals parts expression. Okay. And then we have to token consume again. So I'll change this so that we actually expect the correct tokens, but for now I'm just going to consume. We'll consume again, and that will be the close one. And then we have to consume equal, right? So I'm going to add some comments so I can remember what it's supposed to be. So this is the ident, and that's not how you do comments. Let's see. Ident, and this one is the open bracket. Alright, that's the expression, obviously. And let's see, this one is the close bracket. And let's see, so this one will be, so we consume the close bracket, this is the equal sign. And then we can do this. Dot array dot bracket. Okay, I think that is okay. Func deck, and then this. Oh, okay, actually, hang on. Yes, that's different, so we don't need to worry about that. Okay, so let's add the type array index and then also the array value. So we need a name, index, and value. Okay, yeah, let's do that. So that's gonna be in here. So this is node value. Let's see, so node type word. I guess we don't have that here. So let's add array. And let's go to where we have variable defined up here, so it's gonna be similar to that. Array. And okay. So what this is gonna be is we need the expr index. And we might have to use struct. No, it looks like we do not. Expr index. Yeah, so we have the index. We have a string view, which is the name. Name index, and then also what is what's that last thing? And then the value. Yeah. So expr value, right? Actually, it's expr, so it's an array. So this doesn't need to be a pointer. And there we go. So it's similar to the variable. Okay, do we need all this stuff? Stream elements late, okay. Do we need all this stuff? I don't think we do, because we create a new one, right? So we should be okay. But if we do end up needing it, then I can come back in. Alright, so that should be good. So let's make sure this compiles. Array, okay, so I have two arrays, so I can't call it that. It's going to be array reassign. Right, that's what I'll call it. Array reassign. Okay, type array, yeah, so I did not add the type. So where is that? Yeah, type array reassign. Did I? Perfect. Nope. Alright, yeah, it's index. That's what it is. Okay, so I'll call it that as well. So array index, right? Because we're not reassigning the whole array. Array index. And here as well. Index. Okay. And that works. Okay, so now we can try to compile it. So in here, we need to handle it. So we'll go down to the not part, but gen program. And let's see. So we have case variable declaration, variable reassign. So I'm gonna, since it's similar to this, I'm gonna put it right here. So this is array index. Okay, so array index expression. So we generate the expression of the array. So I don't know whether we want to do that first, actually. But the array value is 0. Okay, and get variable location of array. Alright, we have to get that. I think we want to do that first, though. And we don't want to generate the expression yet, but I'll come back to that. And then we in swap. Yeah, so we put it there. With the index. Yeah, so we actually want to do that first, but we want to induce this because we need to generate the offset, right? Induce that. We can move this gen expression down here somewhere. Alright, so we're going to induce that, and then we're going to have the pointer at the top of the stack. And then we have to generate the offset. So in the same way actually that we did it up here. So I can copy some of this. So we have this. We have the type, so we'll have to get the type as well. Let's copy this whole thing, because it's actually going to be very similar to this, but we're going to write to it rather than read to it. Reading from it, rather. So, right here. Alright, let me put it like that, and there we go. Alright, so the type, I'm going to put that right up here. Okay, so we don't need to in loop. We generate the expression, so it is node value dot array dot index. Okay, and then we push the type size multiply because that is going to be the offset of it. And then yeah, so multiply decrement stack size. We add decrement it again, so that's going to change the pointer. It has to avoid pointing. Obviously a lot of this can be extracted away, which I'll work on that after I finish this. And then we push the size again. We're going to gen right. But first we need to push the data. So we're going to gen expression. That's going to be this actually. Gen expression. Okay. We don't need a pop, I don't think. No, because then we need to... That's actually all that we need to do. Because we don't have to change the pointer, because we're updating the pointer. Yeah, because it's in a row. So, I think it's fine actually. So I don't know that we need this. Why do we have this DA append when we reassign? But I don't know. That's a good idea, is it? Because we're modifying the array. Yeah, but I don't think we need that. I think that actually messes stuff up. So I got rid of. Yeah, we don't need that. So let me try to compile this. And with some issues, then an indupe means state as well. Okay. Expression undeclared. What? Oh yeah, so we don't have expert. It is node. Where we use yeah, it's right here. So node value array name. Okay, that compiles. Let me try to do it. So clean payment. Yeah, something like this. So name payment. Hasn't. Let's look at that. Okay, so we have array index right here. So indupe 0, so this should be the pointer. Push 5, so that is the index, yeah. And we push 8, and that's the size of it. So we multiply those together, and then we add to the pointer, cast it back to a pointer. Push, this is the size to read. What's the 27 for? Okay, that's the new data, actually. Yeah, so that's the, oh shoot, I think we need it in the other order, don't we? We push the data to write first, and then the size of it. Yeah, so we have to move that around. Oops. Just like this, basically. There we go. And then that's it. And that should be the right order. Yeah. Okay, so let me try that. As a build tire. And 32. Okay, so it did actually work. So we changed the value stored in the array. Yeah, that's pretty nice actually. So we should be able to change each element, right? So we could use a loop or whatever and change each one. But let me try x3. We'll set that to to 15, right? And we'll try to access x3 plus x5, right? So that would be 6 plus 15, so it should be 21. Higher. Okay. And a save voltage. Okay, so it did not work. Okay, that's interesting. So it's seg voltage when we're okay. This is probably why. Alright, so something happened. Something happened to that. For some reason it oh shoot, I see why. No, because that actually consumes that, so that's not why. Okay, that's not good. I could probably use GDB, or I could just add a print statement right here. So it's when we get this. Let's print the stack size and the index. Stack size is that. Index is that. Stack size and index. Okay. Let's take a look at that and see why it might be that. And that is that's okay. It's doesn't matter. Okay, stack size 1 and index is 1. So we did okay. Oh shoot, but that was the other one, wasn't it? Yeah, this was no, hang on. Oops, 0. Yeah, so that okay, that's when we're reading it. So that's actually in this one. Up here. In the gen expression right here. Did I forget to subtract something when we were changing the stack size? That could be it. Okay, let's actually print out this here as well. Stack size is that, and then index is that. Stack size. Okay, let's see how that looks. Again, we have that, but that's fine. Okay. So stack size is 0. So for some reason it's 0 right now. Why is that? That is, yeah, that's very wrong. So is it something with the write or the read? Actually, hang on. Yeah, this consumes 2 elements. Because we're not, yeah, that could be the issue. That could be the entire issue. Okay, that looks better. Yeah, and now we don't have that. So let's see actually if it works. So yeah, I'll sort of talk about what just happened, but I'm pretty sure this should work. And it's still saying going. Okay. Is there another one? No. Push 32, add. Okay, so I'm going to need to probably step through in GDB to see why it is segfaulting. Yeah, but that was still an issue. Basically, what the issue was is read consumes 2 elements on the stack, not 3, and I was subtracting 3. Okay. Let me look, actually. So, we push this size, and then we had the pointer as well. That's it. Okay, so that actually makes sense. Alright, so as for why it is doing that, I'm going to have to find out. So, build tire. Panel 10. So we can step through in GDB, yes. Alright, next I need to... Actually, it is not built with debug, so let me actually add that. I'm just going to add it here, because I don't know how to change the build type. I don't know. I can worry about that yet. Yeah, now we'll build it again. Okay, and that way I can use that. So let's go back to script build, and we can run that GDB command again. And okay, we'll just do this. Enable, and we'll break on read program from file, and then run with yeah. Okay. Yes. Step through this. Okay, and so this is not what I want to break on first. So let me go through this whole thing, and then run instruction. This is what I want to break on. Okay. So I want to look at. Actually, I'm not sure this is gonna be very helpful. I basically want to look at the stack. So let's display machine stack. No, I want to look at all the instructions. Machine instruction. IP. Dynamic display. Okay. Push. So this is a push. Alright, this actually is gonna be very helpful. I think we better just add a couple of things and see where we're actually failing at. So let me read through it and see if I can figure out where it's at. So it's gonna be, it could be with the array index here. So is this wrong? Push 3, push 8. So that's right. And that's what we're running here. We're running 15 there. Hang on. So okay, x3 and x5. So those are valid indexes. That's not the issue. So we have a single variable declaration, indupe 0. So that is, what are we duping it? Yeah, so we're reading the value from it. So that's what it is. So this is the pointer. Push 3 and then 8, so that is the index that we're indexing, so that should be fine. To avoid pointer, push 8 and read. Did I do those in the wrong order? No, I don't think so. I can make sure as well. Let's see, and let's just look at int read. So first, how the stack is the size. The other one is the pointer. Okay, yeah, it wouldn't work at all if it was the other way around. So actually that makes a lot of sense. Yeah, so we have the pointer and the sides. Read. Shoot. This is not right. Then we're in dupe 0, but that is what we just read, the value that we just read. So read does not consume 2 from the stack because it pushes a new thing on the stack. Okay, that's a big part of the issue. It consumes 1, but the fact it pushes a new thing, pushes the value. So that is important to consider. So now, yeah, so we have that now, and now it's going to be in dupe 1. So we're going to correct that. Chasm. Fire. Volcano tip. And there we go. 21. So that is correct. Okay, let's try just one more. So we'll make it 22, right? Look. 0 indexing. Perfect. Yeah. Okay, yeah, so it should be 22. And there we go, 22. Okay, very cool, very cool. I'm gonna get rid of the print statements now, actually. So J transfer. Give it this one. And then also array index. We have that here. Okay. Yeah, very cool, very cool. Hey, Alvaz, how you doing? What is up? How's life? Building a game in Godot. Nice, nice, nice. I'm good, I'm good. Have you used Godot before? Or this like a new thing? Okay. That's okay. So that's pretty cool. I'm gonna add some labels though so I can tell what's going on here. So let's see. New thing you want to test some art? Nice, nice. What do you think of Godot? I used to use Godot. Not very much, but some. So, in this label, so let's see what each, like I want to sort of document what's going on. So we have the type. So this is the gen offset, basically. Gen offset. Let's put offset probably. Okay, and that's what that whole thing is. And then this is the expression. So we can add that. This is not expression, so I can do that. And then right here is the right. I don't really need to say that. This is the size though. Size. Okay, stuff like that. Then I'm probably gonna move this into a function because it's pretty much the same thing. It's very cool. Are you using GDScript? I think that's what it's called, or C#? Because I think you can use C# with it, right? If I'm not mistaken. Okay, actually, so go to. Let me compare this to gen expression. Trying to roast crab and a gopher. Nice, nice. That's not right. Hang on. Right here. Okay, and this one is pretty much the same thing, right? Can I copy? Yes. Okay, so I just want to look at and like compare them. So we push the type. Let me indupe that. Gen expression. Gen push. Multiply. Yeah, so that's all the same. 2 void points. So it's just this last part that is the same. The read and write. And also we push the value here, so that is different. So we can, this whole offset thing though can be a function, right? I like to use C#, but for now GDScript. Okay, okay. I'm not like, so it's made for GDScript, right? I don't think like C# is sort of just something that has come out over time, if I'm not mistaken. So I want this. Yes, okay, okay. Do not want that one. Alright, so just this basically. So we get, well, we need the type anyway, so we can probably even pass that. I think that makes sense. So it's just going to be the indupe onward. So this will be the function. So let's see, we get rid of all this because it's the same thing. So basically, we're going to gen array offset. Save file. Okay. So we have we need the file. We'll need the index as well because we don't want to get it again. And then the type. Okay, the type. And I think that's actually it. That should be good then. And this should generate just basically this whole thing here. So I'll grab that and I'll make a nice little function up here. Array offset. I'm gonna move it upward with the other gen ones, but not yet. Paste that in there. One more. Okay, and one of those. And okay, so this is gonna be the program state file. What was the other thing? So we need type, but that goes after the index. Okay, something like that. Okay, I think that is good then. Hopefully. So generate offset. So we're gonna call that. Okay, generate offset. So that will be it down here as well. Thanks. Go away. Have what is it? Type array. Yeah, type array index. So instead of all this, we can just gen array offset, save file, index, and type. Get rid of all this stuff. to that point. And let's put this in that fucking array offset at the top. Why not call it that? Oh, gen array offset. Okay, I'm gonna change the name because we don't need the AY. Okay, time to build that. Unused variable type. But we pass it, do we not? Node undeclared. So we don't have node. Wait. Where did we do that? Okay, so that is the... Okay, so we need a few things here. This is the var index. And then expert. This is the array index. Okay. Yeah, then we can use that. So we can pass this array index, and this one is var index. Okay, because this is like the position of the variable on the stack, and this is the array. Alright, gen array offset. That's not right. Gen array offset. We need to pass that. So node value dot array dot index. Yeah, and this is the same thing. Node value dot array dot index. Alright. Make unused variable type. So why is that? Oh yeah, because I left this stuff there. That's not bad. Make node undeclared. Oh yeah, because it's not node. It is expert. My bad. Make that compiles. TASM, let's take a look at it. So there should be some labels. Offset, so there's the offset. And we should, we have the offset there as well. Okay, so let me try to compile that. TASM, well, assembly rather. Oops, it's this. That, and 22, so that is still correct. And, let me add some more labels. So what are the other labels that we need? So like, what's going on here? So we have the variable declaration. Yeah, okay, so for the, because it is an array, this is going to be a label of, the expert can go down here. Okay, this is the array, so this is, array allocation. And then we write to it that many times. Well, actually, okay, so this is the array allocation. So a lot of white space. Okay. Like that. And then this is each index. This is index that. Can't really pass it like that. Yeah, no, we can't. Okay, index that what? Let's do that. That's the index, right? That we are generating. Okay. And then we also have the expert for where the value is. Even do that value, right? Or expert. Like that. Okay, and then we don't do that. Let's see, that should fill up a lot of the space here. And there we go. So now we actually have some labels. If I open it again, it will look a bit better. Because it actually handles the comments and stuff. Some of the keywords are not updated. But basically, we have array allocation, right? That's what this is. And then index 0, so that's index 0 that we are doing here. And then this is index 1, index 2, index 3. And then this is actually getting the value from the array. Oh, no, it's changing the value from the array, rather. Yeah, because of the right. And then this other one, that's the offset, but we should really say indexing array or something like that. Getting the value from the array. Like, there's indexing changing it, indexing getting it, right? Anyway, it's not like a big deal, but it just makes it a bit easier when reading through it. Okay, that's good. Very good. So, yeah, that's pretty cool. Let's see. So, what I'd like to be able to do is also to declare strings in a similar way. It's like, x stir equals a string, right? Like that. Probably probably won't have like, you know, x char 12 equals, whatever, like that. But instead, this will be the syntax for it. So a string, it's just an array, right? It's the same way C works. And then you'll be able to index it in the same way you would with an array. So to do that, we need to add to the expressions the ability to use strings, right, as parts of the expression. Because this would be an expression here. Then we could also do this, and we could just look at this, right? And as long as they are both strings, like if you do string plus 12, that's not valid, right? If you do something like this, it would just like concatenate the strings together. We could just call to an internal function and do that, and I think that's reasonable to do. Same with equal and stuff, right? Equal, so something like that. But yeah, that basically this is what we do. Let me think. That's going to declare it, and then we can index it the same way and just change. We could change specific values or get specific values. Like let's set this equal to. I'm not sure if I would have characters necessarily, but I say just one character strings. I'm not sure. I'll have to think about that. But something like this, and then obviously we get the value stored using this as well. And then we could like do string compare and stuff like that. Implement that. Yeah, and add it to like the standard library or whatever. Could be cool. Alright, but that's not yet. So now I'll probably go through and probably add some errors if you do things wrong. Like so right now, you can access out of bounds. So I don't have a way to check that yet. I was thinking about changing the virtual machine so that it pushes the size of the array as well, or the capacity of it rather. So then you have the capacity of the array always. So you can't change the value out of it, and that would be useful. Yeah, but I'm probably not gonna do that yet. Let's see. So what is something that could be changed right now? That's like simpler, without changing the actual underlying virtual machine. Well, I can commit this, first of all. Commit array index reassign. Okay. So yeah. Let's see. So I'm not gonna add types yet. That'll probably be the next stream. I'll work on strings. But for this one, okay, let me look at sort of how I'm hitting it. In here, in the parse, right? Just regular parse. And if we look at ident, and we have this. So let me actually add error handling here, because we don't check to make sure it is brackets and stuff. Okay, so ident. So this should be yeah, okay, so what to expect, well, we know that's an identifier already, so we're good with that. Then this one is an open bracket, so if token consume type is not equal, token type open bracket, then we want to just run an error, right? Print error. Alright, the print error macro is not very good, so I'm gonna do it on a new one because I have to put a lot of information in. Tokens.data 0.location. So here's the location. Expected open bracket, but found that, and then print the tokens.data 0.type and we want token types. And this will print the string representation. Okay, then you need to basically do the same thing for all of these. So this is a closed bracket. And actually, we don't need that for this one. Because we already know it's an open bracket because of this, right? Because that's what I'm checking. We peeked ahead, so we don't need that. And then we have equal sign, so we can do that here. Yeah, so I do have functions for this, but it's kind of messed up, and I need to change it. And I don't want to do that yet. Token type equal. Expected equal. Okay, append that. So that should be good. So now we should be able to just put random stuff in there. So if I open Arcano, so this is for this, right? That is what we are looking at. Yeah. So yeah, I shouldn't be able to put something like that in there. That would be invalid. Expected integer, found that. Yeah. Okay. So that works. And then we also have. Well, this first one we know that. So we have this. That's gonna fail. That's gonna say equal sign. Expected integer, but found that. Wait, what? I'll mess this up. I did. Oh, because I don't consume that anymore. I actually got rid of the consume. Okay, that makes sense. It's not, I didn't put this is, okay. Whoops, I can close that. Okay, pino.get. So expect to equal kind of, there we go. No, that's still not right. What? Because there's an extra token consumed there. Okay, yeah, got a little. That should work better now. Now it should actually work, hopefully. Okay, it did actually work, but now if I modify it, that's not right. Pino. Yeah, so if I get rid of that, it should say expected close bracket without equal sign. Open bracket. This is close bracket. Okay, yeah, the error message is wrong, but it was actually right. Close bracket without integer. I'm not sure why it's an integer. Okay, yeah, because that's what we're currently on. Okay. Yeah, that's fine. So it says the proper location, all that stuff. If we get an equal sign, then that's not either. Yeah. Okay, so that all works. That all seems to work. Okay. Okay, and let's see, I just want to look at this. We already know both of these, so we're going to check those. Here, we should probably check some stuff. So here's the equal sign, right? And what is it? No, that's the identifier and the equal sign. So we don't actually have to check anything because it's already checked. Ident and, oops. Equal. Okay, so we're good with that. We appended that, so that's all good. All good. Rate indexing is supported. Oh, shoot. I forgot I added this yesterday. Yes, we don't need it. Okay, yeah, so we just had an extra one there that wasn't doing anything. So let's see. If we look to parse primary now, parse primary, right here. I think we need some checks here as well. So type open bracket. So that's what we consume here. So we're good here. This is open bracket. Then we consume, and it should be closed bracket. So if it's not a closed bracket, then obviously we have a problem. Then yeah. So same thing. So print error tokens data 0 application expected close bracket found. This is when we're reading from the value, right? So like in an expression. Token types tokens data 0 dot type. Okay, and then make sure that compiles. It should, assuming I did not spell anything wrong. Okay, and let's try it out. So if we're in here and we do that, then we should get an error. Okay, close bracket found item, perfect, and that's 6 down. That's a G. Why is it 6? What? Yeah, that's just way off. Okay, I should probably look into that. The air handling is very messed up. Oh, like this is completely wrong. I don't know why it thinks it's there. Yeah, that'll probably be a separate stream on its own, just fixing the air handling in a lot of ways. Okay, that's pretty good. That's pretty good. So yeah, we handled that. Okay. Yeah, so like it's, becoming a lot more powerful, the language. Okay. Yeah, because we have functions now, we have arrays, so once we implement strings, we'll be able to implement a lot of string operations. And then also, we can also, I think that like this is pretty much enough to implement something like rule 110. Should be most of that. So that'll probably be pretty soon, just to test the language, make sure it holds up, right? Yeah, and then I'll start building up examples, tests, and things like that to make sure I don't break anything, Okay. So that's cool. Let me look here. Let me add a gen add and stuff. So let's see. I have a gen down here, don't I? Generate oxide. I'm going to move that up here with the other gens. Whoops. And there we go. Alright, like that. There we go. And then, yeah, so I want like gen add. Gens, like just all of them. Add, sub, all that. Okay, and that, it subtracts 1 from the stack. So I can probably go like right up here with these. So it's like pop, right? So gen that. So this is add. And they all are pretty similar. So this is give. We do have mod as well, but I don't really want to like that. Sub. This one should be sub, and this one should be multiply. Mole. Okay, so this one's gen mole. Gen sub. Gen div. Okay. And then I'm gonna use that, you know? So whoops. And anywhere that we have gen, not that, but like add. So this can be gen add instead. Also, we don't subtract anything from here. So is that causing issues? But we push. So that's why it's not. But this should be a gen push anyway. That. Okay, get rid of that. Gen add. File. We don't need this one. Okay. Make sure that all compiles. And make sure everything looks good here, and then test it out. And 11, is that right? I think that is right. No. So something is very wrong. Why? That's all that I changed right now. So let's see, this is supposed to be 3. So wait, hang on. Oh shoot, it's because I am indexing on the bounds here. Yeah, and we don't check for that, so that's why. Wait, so hang on. That's interesting. So that added it didn't like save fault or anything. So it probably was closed up. But yes, that should be 0, 1, 2, 3, so that should be 4. Plus 6, so 10, and then so it was actually the right number. Okay, so I didn't break anything, but yeah, so I want that. So then that would be 15 plus 6, so 11, so it should be 21. Time. 22, that's what I meant. 22, yeah. Okay, that is good. Let's see, what else? Add. So gen add. Some gen mode. State file. Get that. State file. Okay. I have any other ones? Just that. Okay, and then sub. I don't think there's any sub. Mole. I think there might have been another mole. Gen mole. Okay, we need to do the same thing here. Gen mole. State file. So get rid of that, and then this is gen push. Okay, and get rid of that, and then gen expert. So we should be fine. Should be fine in terms of that. Alright, no more like that, and no. Okay, let me just make sure that it all still works. The same thing, right? That's some TASM, TASM. Field of tire, that, and 22. Okay, so it all still seems fine. And now it's a bit more abstracted away, sort of. Really it's just consistency, and then it makes it easier. Yeah, easier to do things. So is there anything else that I want to separate into a function? Maybe like not really one for creating label, because it would literally just change removing these two characters, the comment and the space. So I don't think that's worth it. Um, and we don't, yes, we don't need this. Or this. So we're good with that. Okay, there's a lot of stuff being appended to here. That is also a thing. Why do I do this and not just, set? Oh, hey, so I want to zero initialize. What else is there to a function? Let me look at that. There's only the 3 parameters, so yeah, I don't need to zero initialize anything. I mean, yeah. Okay. So I can change that. I can do this, type equals node value dot deck type, and then dot arrays equals node value deck dot arrays. And then wait, actually, is the func deck just a function? Let's do this. Value dot deck. Does that work? Let me see if it compiles, because if they are different types, then it won't. Okay, yeah, because you can't really do that. But, can I mem copy? Yo, what's up? How you doing? And thank you for following. Can I do this? What else is mem copy? Oh, it's probably the size, right? Yeah, size of function. And it goes up here. Okay, that compiles now. This is still work. So if I declare a function, it works. Really cool. So let's open Phano. I'll leave this there. So let's do main. It's int. Write a tokenizer for your line in JS. Nice, nice. How'd that go? How is JavaScript for that? I haven't done very much with JavaScript in quite some time, so yeah, not very familiar. I'm testing that this still works. And okay, whoops, that's not. Right, and then if I call the function, then yeah, it should work. Okay, yeah, that seems fine. And that looks good. Finished it and didn't finish the lecture in C, so that says something. Yeah, that's fair, that's fair. Yeah, makes sense. And, it is a lot higher level, so it makes sense that it would be, well, actually, yeah, I know I should do that. I just, too lazy to make things easier for myself, so I've not done that. I do actually want to, like, integrate it so that when you, call it, it, like, does it all for you, like, it calls the functions, assembles it, and then also runs it. So it would just be like, you run this, and then it would compile it, assemble it, and emulate it all at the same time, Yeah. And I think that's the reason I didn't do that, because I thought I would have already have implemented that before I got too far along, but then I have not. So it's kind of like, I don't know if that makes sense, but basically, hopefully it made at least some sense. I should have a label for the function. Okay, I want to look at how that looks. So that's going to be down pretty far because it's after all that other stuff. Var declaration. And I didn't recompile it, so that's why the chat. I'm use Vim because it looks better. Okay, function declaration, yes. Okay, so that's better. That is better. Okay, that makes sense then. Okay, so that's a bit nicer. No, I don't need to do the same thing there. Mhm. Yeah, so I want anything that like modifies the stack to be in a function, so I can make sure the stack is correct, you know? Except for like certain things, like the native things. I'm gonna need to implement a few other things before I can move those all into their own function. But everything else pretty much. Like yeah, this one, because exit consumes one thing, but it's still just called a native call, so I need to work on that. But that's basically yeah, because like write consumes two, because it has the pointer argument and then also the file descriptor, right? So like standard out or whatever. Mm-hmm. Okay. Yeah, so once I implement strings and other data types, I'm gonna make sure that you cannot add two things in different types, right? So you can't do string stir plus 15. And I'm gonna do that on the level of the parsing, right? So while it's being parsed, and I think that makes sense, you know. And then then when we get here, we don't have to check a bunch of stuff. So I think that makes sense. Okay. Yeah. So looks pretty good. I think that's really gonna be about it. So I got everything done that I wanted. Which really just is, you know, being able to index the array. Actually, I want to see what happens. So if I try to index out of the array, like I'm not gonna get an error because we don't have any bounce checking. So if I do this and do 6, right? So that's gonna be 1 out of it. What's it gonna output? I want to see. Whoops. 0. Okay. That's interesting. We do 0. Hmm. Okay, ham. Is it it's just garbage data. So it's hard to tell. I'll probably make just like a simple bash script for this. Okay. To sort of run bash. Okay. I wanna see the commands. And then yeah, so that's dot slash main. I'm not gonna take the arguments because this is like the test file. So build as a km as a build. It's just temporary. So yeah. All right. And yeah, all right. Let's try that. Okay. Pretty cool. Okay. Okay. The output of it is this. Actually, I don't know that that's gonna show the output. Will 32. Okay. Really different every time. Yeah. So right, if I change this, is it going to show that as the output? So 1 as the output. Okay, it looks like it will. So I just want to make sure. So like something, you know, let's do grab 4. So that should be 5. Okay, yeah, that's a lot nicer. A lot nicer. Okay. So, and really this is kind of like a string. You know, an integer array could be used as a string in a way. You know, where it corresponds to ASCII values. We just don't have a way to like use that as a string because it needs to be assigned in UN8 basically, U8. Because that is what a character is basically. Yeah, because these are all 8 bytes wide, so it doesn't quite work, but it could be if you casted it properly. Okay. Alright, so I guess I'll commit that, and then I guess it's gonna be the end of the stream for today. Okay, so basically, to if I'll push all that. Okay. Yeah, so the next stream, strings, right? That's the plan. So declaring strings, it's gonna be a similar process to the arrays, and then also indexing them. Once we can do that, then we have a lot more stuff we can do. Yeah, and that's gonna be pretty fun. Then it's pretty fun. And it is indeed pretty fun. So that is gonna be Yeah, that's gonna be the end of the stream. So thank you guys for watching, and I'll see you next time.